Hey guys, Mr. A here. This is homework for page 165 and 166. This homework is due tomorrow. Let's get started. Question number one says, after you read the example, it says, what type of lines are shown in the graph of the system of the equation in the examples? So what type of lines are these? We should know by now that when we have both lines like this that are not touching, that they're parallel lines. So for number one, you should tell me that these are parallel lines. So number one should be parallel lines. Number two says, the graph at the right shows this system of equations. Y equals x minus 3, y equals negative 3x plus 1. What is the solution? Explain how you can verify that is a solution to both equations. So we know that when the lines intersect, when they intersect like this, we know that it's a one solution, and the solution is where they intersect. Okay? So the ordered pair of where they intersect will be our solution for this. And that ordered pair right here will be 1, negative 2. So my solution here will be 1, negative 2. And the way I can check that and verify that is by plugging in my x value. So my x is 1 and my y is negative 2. I can plug that into my equation. Now my equation is y equals x minus 3. So I'm just going to substitute my x value and my y value into the equation. So my x value is 1. So when I plug in 1 for x, I should get negative 2 for y. So y should be, when I plug in 1 minus 3 is negative 2. So that tells me that my x and y values are correct. All right, we're on page 166, question number 3. Question number 3 says, the graph at the right shows that this system of equation, y equals 2x minus 3, y equals 1 over 2 parentheses 4x minus 6. Explain what the graph tells you about the two equations that form the system and about the number of solutions the system has. So just straight out the bat, as soon as I see that there's just one line, I know that this has infinite many solutions, because for there to just be one line, that means both of the equations are true. While both of the equations doesn't look the same, when we solve the second equation, y equals 1 over 2 parentheses 4x minus 6. Remember, if you have parentheses, you use the distributive property to get rid of the parentheses. So as soon as I do that, I'm going to get half of 4, which is 2x, half of 6, which is 3. So y equals 2x minus 3 is the same thing as my first equation, which is y equals 2x minus 3. So that tells me that this has infinite many solutions. And question number 4 says, describe two ways in which you can determine how many solutions the system of equation has. The two ways that I can determine that, the two ways that we've learned so far is, one is by graphing, and two, by slope-intercept form, which is what I did right here. By converting this in slope-intercept form, I can be able to tell what type of solution it is. So one way is by graphing it and looking at the graph. The other way is by making sure that both of the equations are in slope-intercept form. Question 5 says, how many solutions does this system of equation have? So before I can check this, I have to make sure that both equations are in slope-intercept form. The first equation, y plus 2x equals 5, is not in slope-intercept form. And for me to get it in slope-intercept form, remember slope-intercept form says y equals mx plus b, so that y needs to be alone. So the only thing with this y on this left side of the equal sign is this 2x, and it's a positive 2x. So for me to remove it, I need to subtract by 2x. And whatever I do to one side, I have to do to the other side. So I get y equals, this is going to cancel out, and I have minus 2x plus 5. So that's my first equation. My second equation is y equals 3x plus 5. Okay? So now I need to check my slope and my y-intercept to determine what type of solution this is. My slopes are different, but my y-intercept is the same. So we know that if the slopes are the same and the y-intercept is different, it's a no solution. If the slopes and the y-intercepts are the same, it's an infinite many solution. And if it's not one of those two, then it has to be one solution. So I know that this is a one solution. And just by looking at it, I can tell that my solution is going to be that 5 where they intersect, where that y intercept is. So for number 5, how many solutions does this system equation have? I'm going to tell them that it has no one solution. Question 6 says, Jason and Sylvie work together to write systems of equations that has no solution. Jason wrote the equation y equals 4x plus 2. Sylvie wrote the second equation. Write a possible equation that Sylvie might have written. Explain your reasoning. So for an equation to have one solution, it either has to have different, meaning different slope, different y-intercept, or different slope, same y-intercept. So we can kind of do this in two ways. All we need is a matching equation to go along with this y equals 4x plus 2 to make it have no solution. So for a no solution, we know that we have to have the same slope, different y-intercept. So we have to have same slope. So our slope is 4, so we have to have that same slope, but our y-intercept has to be different. So I can use any number here. I can use -2 because +2 and -2 is different. So you can use any number here as long as your y-intercept is different, and that would tell you that it has no solution. All right, that's it. That's page 165 and 166. That's your homework that is due tomorrow.